In question 10, we have an object moving around in a circle at a constant speed of 4 meters per second, and we're asked that if the object has an acceleration of 9 meters per second squared, how long does it take for it to complete one revolution? A couple of things to remember. One revolution means one time around the circle. And the distance traveled one time around the circle is equal to the circumference. And the circumference of a circle can be found as 2 pi times its radius. We're also told information about the acceleration and speed of our object. Because our object is moving in uniform circular motion, we have an equation for the acceleration. The centripetal acceleration is equal to speed squared divided by radius. So what do we actually need to solve for? We're asked how long does it take to complete one revolution? Another way of saying this is how long does it take for our object to move a distance of 2 pi r around the circle. We can think of speed as distance divided by time, or in terms of variables, 2 pi r divided by t. We can solve this equation for time, so we'd have 2 pi r divided by the speed, and if I know what my radius is, I could use that along with all of the other information I'm given to solve for the time. So now the task is to figure out what is our radius equal to. We were told information about the acceleration and the speed, and we want to solve for the radius, and we can do so with the centripetal acceleration equation. Radius is equal to speed squared divided by acceleration, and we can plug in numbers. 4 meters per second for the speed, 9 meters per second squared for the acceleration, and from this we can calculate a value for the radius, which we can then use in our expression for time, and using a calculator to calculate all of these products and divisions, we would find that this is equal to 2.79 seconds, which rounds to answer choice D. Problem 11 is a kinematics problem where a car is stopping with a constant acceleration of magnitude 2.3 meters per second, and we're asked how far will it travel before stopping if it has an initial speed of 20 meters per second. For this problem, it helps to write down what do we know and what do we not know. Our big unknown is how far does the object travel. We are told that the object is stopping with a magnitude of 2.3 meters per second squared for its acceleration. So I can say acceleration is equal to negative 2.3 meters per second squared, and again the negative is there because the acceleration needs to go in the opposite direction of motion in order to bring the object to a stop. Because it stops, we know that its final velocity is going to be 0 meters per second, and we're told the initial velocity is equal to 20 meters per second. This is enough information to now calculate the unknown distance. Because we're not given any information about time, the kinematic equation that's going to be most useful for us is the one without time. We know that our final speed is 0, and we can take our initial position to be 0 as well for simplicity. We can solve the resulting equation for x and then plug in the values we're given. 20 meters per second for the initial speed, and negative 2.3 meters per second squared for the acceleration. If we plug these numbers into a calculator, we get that the distance traveled is 86.96 meters, which rounds to answer choice C. Problem 12 is a projectile motion problem. We're told a projectile is fired from ground level at an angle of 35 degrees from the horizontal. It reaches its maximum peak height at time Tp, and we're asked what is the projectile's horizontal position at some later time, 3.1 seconds. This is a two-step process. But before getting to that, let's draw a picture. Here's the ground. Here's the object. It's fired at some angle and then travels in that trajectory. We're told theta. We're told the time at which the object reaches its peak height, and what we want to know is how far in the horizontal direction has our object traveled after 3.1 seconds has gone by. So we want to know that distance. For projectile motion, horizontal distances are given by our initial x velocity multiplied by time, because there's no acceleration in the x direction. We're given the time we're interested in. This will be 3.1 seconds. This is what we're trying to solve for, and we could do that if we only knew what our initial x velocity was. To do that, we need to go back to the other information that they told us in the problem, namely that the object reaches its highest point at time 1.8 seconds. The fact that the object is at its highest point gives us some clues about its y motion, namely that its y velocity is going to be equal to 0 at time t equals Tp, and from that we should be able to figure out our initial y velocity, and from that get our total initial velocity, and from that find our total x initial velocity. So a couple steps to go. First one though is to figure out our initial y velocity. Going to our kinematic equations, one of them says that y velocity is equal to initial y velocity plus at, but we know that the acceleration here is due to gravity, so we can plug in negative g for a, and so our equation looks like this. We also know that initial y velocity can be written as total initial velocity times sine theta, and we're actually given theta, so that's good. If we look at the motion only from the beginning to the highest point, we can say that our final y velocity is equal to 0, and we actually know all of the other quantities except for initial velocity, which we want to solve for. So if I solve this equation for v naught, I get that it's equal to g times Tp, because that's the time that the object's at the top point, and divide that by sine theta. We can plug in the values for our given quantities: 9.81 meters per second squared for gravity, 1.8 seconds for the time to top, and then sine of 35 degrees for our angle, to get the initial velocity is 30.79 meters per second. We can now use that to figure out our x motion. I'm going to copy this and move it over here, just so that way there's more room to work. Our x initial velocity can be written as v naught cosine theta, and the t just comes along for the ride. At this point, I just found v naught, I was given theta, and t, I'm told, so I have all the information I need to start plugging in numbers. 30.79 meters per second for v naught, cosine 35 degrees for the angle, and I want to know the distance at t equals 3.1 seconds because that's what the problem asked for. Plugging this into a calculator, I get that the distance traveled is 78.19 meters, which is roughly equal to what's shown in answer D.